Example 3, find the upper and lower sums for the region lying between f of x equals negative x plus 5 and the x-axis, and x equals 0 and x equals 2. So first of all, we're going to find basically the area underneath the curve, which is what an integral will do. So let's take a look here. Okay, so here is the coordinate plane. First of all, let's graph the function. So it's going to start up at 5, and it's going to go down 1, and 1 to the right. Okay, and we're going to find the area underneath this line down to the x-axis between 0, x equals 0, and x equals 2. So in other words, we're going to find the area in yellow here. Okay. We're going to do this two different ways. The first way, we're going to use this idea of lower sums. So what I'm going to do, I'm going to break this trapezoid up into the area of a rectangle. For instance, if I draw a line here, okay, so this line goes up, hits this point here, and then I'm going to draw a line like this to create a rectangle. So there's one rectangle. Okay, and I'm going to keep the width here of this rectangle consistent. So that was 1 unit. I'm going to keep this, the next one, 1 unit. Okay, if I found the area of this rectangle and then found the area of that rectangle, that would give me an approximation of the area of what's shaded in yellow here. But obviously you can see here the area here. This is not going to be equal to the area that's shaded totally in yellow. It's going to be a little bit less. This is known as lower sums because no matter how many rectangles I pick here, because I'm picking points in rectangles that are lower or underneath the curve, the area is always going to be a little short. So let's put some more rectangles in here. Again, all of these rectangles are going to be underneath the curve. Now my approximation of the 1, 2, 3, 4, now it's going to be a little bit more accurate. And I could continue to shrink the width here. And as I continue to shrink that width, the area underneath the curve is going to be more and more accurate. Okay? So let's go ahead and go through this formula here. Okay, so the first thing we're going to talk about, we're going to find the delta x. This delta x, the width of that, notice that that's the same all the way through there. That's going to be known as dx, the change in the x values. So I got this point, this point, this point, this point, this point. I'm going to call this point x sub 1, x sub 2, x sub 3, x sub 4, x sub 5. Okay. So to find delta x, we've got this formula. It's b minus a divided by n. Well, you know, the line, this is always going to be a, and this is always going to be b. So the total width is from 0 to 2. Okay, so the width of this is going to be 2 minus 0. And then we're going to divide it by how many triangles that we have. So if we wanted to know the width right here, we would take the total width, and if we wanted 1, 2, 3, 4, if we wanted 4 rectangles, then we would divide it by 4. That would be n. We're just going to call it n for now, because we're going to see what the area underneath this curve would be as n gets larger and larger. Okay, so this is going to end up being 2 divided by n. So that's going to be the width of each of these. Okay, now we need to look at m sub I. So to find m sub I, you're going to do I times delta x. Okay, so m sub I for our problem, I is just going to be, 1, 2, 3, 4, all the way to n, so I'm going to keep that I. And then delta x is 2 over n, so I'm going to call this 2I over n. And what that is going to find is each of these points. All right? So when I is equal to 1, m sub 1 would be 2n. Well, 2n, that would take me to that width. When I is 2, m sub 2 would be 2 times 2, which is 4 divided by n. So that's going to take me to that point. Okay? I sub 3, it's going to take me to that point. I sub 4, it's going to take me to that point. Hopefully that makes sense. Okay, so now that we have these pieces, now we're ready to figure out the lower sum. So the lower sums is going to be lowercase s of n equals the summation. I is going to begin at 1, going to n. F of m sub I. So m sub I would be 2I over n. And then delta x is going to be 2n. Now we know what f of x is. F of x is equal to negative x plus 5. So now I can substitute in here. So S of n equals the summation I equals 1 to n. F of 2I divided by n is going to be 2I divided by n plus 5 times 2 over n. Then we're just going to go through and simplify this. So we still have the summation from I to n. I can distribute this guy through, giving me negative 4I over n squared plus 10 over n. Then I can break this up into two separate summations. So this would be negative 4I over 2 over n squared plus the summation I equals 1 n 10 over n. Then I can factor out in front of each of these summations. So I can factor out a negative 4 n squared, the summation I equals 1 n I, plus I can factor in front of the summation 10 n, the summation when I is 1 to n, and then I can say this is just 1. Then we know I is equal to n times n plus 1 divided by 2. And we know the summation of a constant is the constant times n, so that's going to be 1n or just n. And then I can simplify this. So I can make this negative 2 over n plus 1 plus 10. Then I can multiply through and get negative 2 minus 2 over n plus 10. And then this would finally become 8 minus 2 over n. So that is the lower sum. And I'm going to pause the video here and create another video.